Selamat datang di UPT Laboratorium Penelitian Terpadu Universitas Sumatera Utara. UPT Laboratorium Penelitian Terpadu USU merupakan unit pelaksana teknis yang berorientasi pada pelayanan dengan mengutamakan kepentingan penelitian di lingkungan Universitas Sumatera Utara yang meliputi fakultas dan program studi, lembaga penelitian, pusat unggulan iptek, dan satuan kerja lainnya. Tugas pokok UPT Laboratorium Penelitian Terpadu USU adalah menyelenggarakan kegiatan laboratorium seperti pelayanan, penelitian, dan kerjasama. UPT Laboratorium Penelitian Terpadu USU juga mengakomodasi kepentingan lembaga inovasi dan inkubasi bisnis teknologi USU dengan tujuan agar dapat menghasilkan produk-produk yang bersifat inovatif dan berhasil dimonetisasi. UPT Laboratorium Penelitian Terpadu USU memiliki 1 kepala unit, 3 kepala bidang, 6 kepala lab, 10 laboran, dan 4 staf penunjang administrasi. Laboratorium Penelitian Terpadu USU memiliki 6 jenis laboratorium. Laboratorium karakterisasi struktur bahan melayani pengujian topografi dan morfologi dari permukaan benda secara kualitatif. Laboratorium uji sifat kimia melayani pengujian dan penentuan berbagai konsentrasi logam dan senyawa pada sampel organik maupun anorganik. Laboratorium uji sifat mekanik melayani pengujian sifat-sifat mekanik suatu bahan atau material seperti kekuatan tarik, kekuatan tekan, dan kekuatan lengkung serta penghalusan sampel hingga berukuran nanometer. Laboratorium uji sifat termal melayani pengujian sifat-sifat termal pada suatu material. Laboratorium Renewable Energy melayani simulasi pengkonversian energi dan penelitian yang berkaitan dengan energi baru terbarukan. Laboratorium Biologi Bahan Molekuler melayani penelitian, preparasi, dan ekstraksi sampel. Dan juga UPT Laboratorium Penelitian USU juga memiliki alat-alat penunjang penelitian seperti scanning elektron mikroskopi, atomic adsorption spectrometry, universal testing machine, ball mill, siftronic, melting point, neraca digital, furnace, fuel cell, generator solar panel, wind turbine, PLC, humidifier, sentrifugasi, dan sonicator bed. UPT Laboratorium Penelitian Terpadu USU melayani pengujian karakterisasi sampel untuk mahasiswa, dosen, peneliti baik dari dalam maupun luar USU dan juga memberikan kesempatan penelitian menggunakan tempat dan fasilitas di UPT Laboratorium Penelitian Terpadu USU. Dan topik penelitian yang sedang berjalan saat ini di UPT Penelitian Terpadu adalah Green Concrete, Internet of Things, Arsitektur Urban Design Green Building, Forest Product Technology, Structural and Functional Material, Microplastic and Heavy Metal, Renewable Energy and Electrical Energy, Material Isolator, dan Bioremediation. Sebagai salah satu wujud pengabdian UPT Laboratorium Penelitian Terpadu kepada masyarakat, UPT Laboratorium Penelitian Terpadu membuka peluang kepada instansi pemerintah negeri atau swasta maupun masyarakat umum untuk melakukan kerjasama.
Bidang pelayanan dan promosi Laboratorium Penelitian Terpadu USU mengedepankan moto cepat, akurat, dan profesional. Kami memiliki 6 buah laboratorium, yaitu Laboratorium Karakterisasi Struktur Bahan, laboratorium uji sifat termal, laboratorium uji sifat kimia, laboratorium uji sifat mekanik, laboratorium renewable energy, dan laboratorium biologi bahan molekuler. Kami melayani pengujian dari mahasiswa, dosen, dan peneliti. Laboratorium Penelitian Terpadu USU terus berupaya untuk meningkatkan pelayanan dan berinovasi agar dapat menjadi unggul di Sumatera Utara khususnya dan Indonesia umumnya.
Assalamualaikum, saya Baihaki Siregar, saat ini menjabat sebagai Kepala Bidang Penjaminan Mutu dan Teknologi Informasi di Lab Penelitian Terpadu USU. Tugas utama saya adalah memastikan agar layanan pengujian di lab ini terstandarisasi mutunya sesuai standar ISO 9001-2015 dan ISO 17025-2017.
Selamat datang di UPT Laboratorium Terpadu Universitas Sumatera Utara. Kita bisa menganalisis dan mengkarakterisasi berbagai macam bahan dan material. Selamat kita bisa menguji, kemudian bisa mempublikasikannya sesuai dengan standar ilmiah yang berlaku.
Kami telah memproduksi yang siap dikirim kemana saja. Kami, anggota dari UPT Lab Penelitian Terpadu USU, siap menjalin kerjasama untuk membantu penelitian Anda. Dan kami siap mengabdi pada masyarakat untuk memajukan bangsa Indonesia.
UPT Laboratorium Penelitian Terpadu USU.
Assalamualaikum warahmatullahi wabarakatuh. Good evening, I say to you all, greetings. After that we have take a break and we already take a lunch and we have our stomach full, I hope that we regain our spirits, our focus back, because we will witness the presentations that we will be brought by Insinyur Ali Awaludin, STMN PhD IPU ACPE. To Insinyur Ali, how are you? Okay, I hope that you are ready to present your materials to us, because we are also ready to hear from you, and we are excited to hear it. So, the lecture that we are about to witness is about overview of bamboo grafting, which will be moderated by Muhammad Agung Putra Handana, STMT, as a lecturer of Civil Engineering Department, which also the Secretary of Civil Engineering Department, University of Sumatera Utara. To Mr. Muhammad Agung Putra Handana, STMT, time and place is yours.
Thank you. Good afternoon, everybody. Good afternoon. It's Ali Waludin. It's nice to have you here in Universitas Sumatera Utara. This is your second time here, right? For the first time, it's a conference about 12 years ago. So, yeah, I hope that you have a great experience here. So today we will hear about lecture from Insinyur Ali Awaludin, PhD. So I will introduce him to you. He is a associate professor in Universitas Gadjah Mada from Department of Civil and Environmental Engineering. He's graduating from Universitas Gadjah Mada, bachelor program in 1999. Chulalongkorn University for master degree at 2005, and for doctoral program from Hokkaido University at 2008. Mr. Ali Awaludin is the Secretary-in-Chief in Department of Civil and Environmental Engineering, Faculty of Engineering, Universitas Gadjah Mada, from 2016 to present day. He is also the Executive Director of New Zealand Foreign Affairs and Trade and University Gadjah Mada Community Resilience and Economic Development program from 2013 to 2020. And also the editor of scientific research of a Journal of Civil Engineering from 2021 till present, and also editor-in-chief of Journal of the Civil Engineering Forum, Universitas Gadjah Mada from 2019 till present. Without further ado, I present you Mr. Ali Awaludin, PhD. Please welcome him. Yes.
Inviting me to join to this summer course. I don't know if perhaps should I deliver my talk in Bahasa or in English? Which one you prefer? Okay, maybe because some of my talk is written already in English, but may I just mix with Bahasa for some cases, because in some way it's easy to to deliver my idea in Bahasa because it's already become my native language. Okay, so basically I'm not bamboo engineer, I'm timber engineer. I work many things, research on timber as building construction materials. But in some way, during that period, I also work on bamboo, but mostly or concentrated on connection system. So because connection in bamboo is quite challenging, I don't want to say difficult. It is because if we are seeing bamboo as it is, as a bamboo, as column bamboo, it's not the glulam bamboo, because glulam bamboo is basically close to solid wood, which we can easily treat in many connection way. But now when we are talking about bamboo as a bamboo columns, because we see the diameter from the one end to another is different, it's easy to split and so on, so it's become more challenging, or it is more difficult to solve this one. Then my talk will be on describing the previous method that people have already discussed, develop, and how we can utilize or maybe calculate, because yes, we are engineer, we have to really prove the quality or maybe the strength of these connections in the papers. How is it strong that this connection can sustain, because it is our guarantee as our engineer to provide that our structure becomes safe to be everyone to sit in. So this is my background. Sorry, it is in Bahasa, maybe sometime in Bahasa is okay. I wrote this presentation with my former graduate student. So bamboo, as you know, is strong materials, but it also lightweight and has been utilized for many, many decades for many things, for building, for bridges, also for furnitures. And you will see here two photos I took in Green School in Bali. So I came there and I see the buildings so beautiful, and most of the buildings are covered by the rope. It's not exposed to the weather. So this thing that we need to consider in our design. So they are flexible. If you are long enough, you can bend it without necessary to cut it, because we have a bamboo column. Usually when you would like to bend it, you cut halfway or maybe half cross section. Yes, it is true, because it weaken all the bamboo. But this also prolong the splitting along the bamboo. So this is need to worry about this one. So they are good enough in design, also good enough in maintenance and so on. You will see the airflow nicely, and this is become thing that we are really look for, because they are green, they are renewable and so on. So because we are concerning on, and then connection is always become part of our structure or buildings. We cannot avoid any connection in our structure, because when you would like to have any geometric, or maybe you want to extend the long of the timber or maybe the bamboo, then you have to deal with connection. Then my PhD degree was taken on connection of timber. So this idea also tried to be incorporated with the bamboo material. So this is that I would like to discuss. So next slide, please. This is bamboo from close to my city in Yogyakarta. Bambu petung or bambu bulung, okay? They are separating by what we call nodia. I don't know, internodia and nodia. Oh, terima kasih. Saya lebih senang diklikan sebenarnya ya. If you don't mind, Pak, nggak apa-apa. Yeah. So in our engineering point of view, you have this beautiful cross sections, pipe, good strength, good stability, and they are long enough, but in between they have nodia to separate between two internodia. This nodia function as local stability. You will not see any local buckling on this material because as you have steel, you have a problem when the steel is the ratio of the width over the thickness. They have some local buckling, or either in the flange or the web of the cross section, but in bamboo you don't have it. So this is beautiful. It's good given by the God from us to us. So I don't want to cut it and become the glue lamp bamboo. I don't want to. But sorry, someone not recorded this one, okay? Yeah, so I consider bamboo as it is, and it is beautiful material for our life. Okay, they are, yeah, in many ways, they also have the outer skin, which is protect them from the weather. So they are already good. So please use this in as it is. So that's my concern. But it is difficult on the connection system. So that's why we need to consider this one in our activity. So they try to see the compression strength, the tensile strength, and so on. Is this true? The tensile strength of this fiber along within the nodia is very weak because they are overlapping. The fiber is not straightforward, but they are overlapping. But in terms of compression system, they are still fine, no problem, no need to consider this one. But in terms of tensile strength, we need to really pay attention on this one. Okay, next. Yeah, I think the way of bamboo. So sometimes when we are trying to understand the strength of bamboo, which is become difficult because if we have one long of bamboo, the strength is non-homogeneous from the bottom, middle, on the top. If you are looking from the cross section, you will see the fiber is not uniform. You will see more fiber in the outer side, but you have less fiber in the middle part. So you mean you have anisotropic material. And it is not good for undergraduate students. They have no idea about this one. They just only consider isotropic material. So it's difficult material anyways. So we are dealing with this something which is difficult one. But please, you need to learn more on anisotropic material because this is the renewable one which is we need in our life now. So if you consider for this fiber one, you can see that other side has more fibers. So they have more, they are strong enough. They are stronger compared with in the middle part. So the strength of bamboo become non-uniform along the length and also across the cross section. This is the idea. Continue. Or next slide, please. Okay, this is the work done by my student. We can see they have the shear strength, tensile strength, compressive strength. So if they are comparing with the one, seeing that actually the bottom and also the middle top is that different. So yeah, when you have bamboo now, the problem is how we can grade these bamboo products. So this is something that we are really look for many, many ways. There are no available standard in Indonesia to classify the strength of bamboo because they are really variative, big variation within the tree, also within the places different way. So they are done in my lab, so they have the kind of numbers, and we agree that the tensile of bamboo is good enough, but when we are dealing on splitting strength, really weak. But in terms of connection, when you have bolted, they will initiate splitting. So we need to, take the worst case because if we have this connection as the weakened point. Slide next, please. So they are splitting. They are splitting in many ways, like pyre failure when we have two tension, so they have the fractures. Here the splitting, like the way that in this system, at the end when you do the compressive strength, also maybe the compressive strength at the end, the fiber splitting is always to become the critical one. This is some example we are taking from the pictures. So, okay, next slide. Okay, even though they are under flexures, but flexure also initiating compression at the top or maybe tensile in the middle, also shear strength. And this shear strength also initiate the splitting. So always the final failure of the bamboo is always the splitting one. Next. This is one good example for us as the timber engineers. This big hall made from bamboo was constructed within 3 months, but it then collapsed within 2 months. Okay, so the lifetime of this hall is only 2 months. They are creating this one 3 months. Can you imagine? No one will pay this, big amount of money for only 2 months. So it was just recently, it was constructed in August, September, October, and then they are starting to inaugurate the building in December, and next year, February, early collapse. So can someone suggest what is the within this building? Then I was assigned to check those documents. Those documents, actually, they have no standard on design for timber. On bamboo. So they are copying the standard from timber. They are copying, and they have no any document on the properties of the bamboo they are using. So no properties of bamboo. So they are copying the timber standards. And then the design with the construction, they are going at the same times. Usually we have design document first and then construct it. But they are do the same way. So actually design is just made by local people. The designer only just formal administration, because when you would like to have maybe permission or maybe from the local government, they have to provide the document. So document is just only to fulfill the requirement. It's not being the guidance for the design. And this document is quite thick, maybe hundreds more pages, but only one page is concerning the connection of this bamboo. Only one page. And it's also unclear because only citing some numbers. So which is, if you are become bamboo engineer, please you have to be ready on your, document or your calculation and so on, because it is really now, this become problem now. So many successful bamboo structure because of experience maybe, or maybe luck, but not engineeringly, scientifically proven. So this is the reason. So when they are constructing this hall, within 2 months, they did not protect prepare any protection surface for all the bamboo which is on that construction site. So the bamboo is constructed, the main structures, and then you have the rain, sunlight, heat, and so on within 2 months, and which is unfavorable for the bamboo, this situation. So after that, after the 3rd month, they put the cover, and then just only 2 months after that, they collapse. So because we need to consider the durability in terms of whether, bamboo, when you put outside, you have the weather, it is really, we need to consider this one seriously because it is not durable enough. So in many, many ways, you have many like bamboo structure, they already been covered by rope system and so on. But also during construction, you need to worry about this one. Okay, so I came and I tried to understand the way they design and also the way they constructed, and I finally come to that point. But then another process which is like going to trial for this situation is become complicated. I don't want to join because I don't have much time to support them, because it's just only visit for 1 day or maybe just complete it, okay? So please continue. If we have good construction, good maintenance, it is good enough and really look beautiful for our life, okay? Because they are really paying attention on the durability aspect of the structures. Okay, please next. Okay, now come to the connection system. I think the traditional one usually just using the natural fiber or the wires. This is the normal one. And you may also the steel wire because it's just small enough. And those two systems actually, they don't put any hole. I mean, they don't make any hole on the bamboo. So they are just wrapping on it. They don't initiate any like nail or maybe bolt it, they just wrap it. Because they know bamboo easy to split. So they consider this one. Here also some example. Traditionally, they are connecting with the mortise tenon system, which is known in timber engineering. So they are put some node, so maybe some hole on the bamboo, and they put some like bamboo dowel or maybe timber dowel. They are connecting, and then after that they wrap within the natural fibers. So because natural fibers sometimes during the weather, there's the sun, also the wind, the rainings become weakening, loosening the connection. So using this combination, it is reliable in the future. Next. So this is now we are introducing bolted in our connections. You have bolted, and you need to bolt it, and then they also have some. If you are introducing bolted on those connections, you have the force, acting on this connection system, and then the bolt will be bent. So because actually when you have the shear forces or maybe axial forces, then this long bolted will bend, and this introducing axial forces on this bolted, and these axial forces will push the bamboo and become splitting. This is the idea. So if you are using this one, please consider that I don't know, can I point here? Okay. Oh, here ya. Tidak muncul. So, yeah, just below the nut of the bamboo, the nut of the bolted, they will acting some forces because the bolted will bend and the length of the bolted become longer than the initial length. So it is there is axial forces on this bolted, and these forces compress the bamboo, and bamboo becomes split. This is the idea comes from many connection system. So this is some idea new one. So we can next one. This is the thing that I like so much because they don't hard. They put wires, steel wires. They are connecting, but of course the strength is not big enough. But they don't have any hole on the bamboo. So this is using steel wires connecting, and so the connections really rely on this steel wire system. Okay, next. So this is developed by Masdar, our PhD student in our faculty engineering in our campus. So the idea of this is because she knows that there are compression, there are axial forces coming through the bolted. So they are trying to distribute these forces by utilize small wooden dowel, small wooden clamp. So you will see here the bamboo in the middle, and they have the gusset plate, and in between they are inserting this dowel of the bamboo. Solid wood. They call wood clamp. So the axial forces coming through the bolted will be distributing to all all surface of the bamboo which is in contact with them. So and then the strength become higher. So they don't initiate any early splitting on the bamboo. This is the idea coming from Ibu Masdar. I think she is from Aceh. Yeah, next one. So this is more modern one, but you see many still ball or maybe steel plat and become heavy on our structures. But this is good enough. Actually, they want to transfer the forces from the one bamboo column to another one. So they are transported, and we know bolted more, much better than other material. So they are developing kind of like steel bolt, and they are connecting to one part of one column with some steel dowel or maybe bolted, and they are working as the spectra system. So they are just only tension and compression on the system. I think this one is common now, applicable in many ways. So please continue. I think this is also the same. So they are now in modern, we have steel plate, we have dowel, steel dowel, and we also have steel balls. They are become key points. Okay, then the idea coming from Professor Morisco, when we have the connection on bolted. So please, back a little bit back. Okay, next. Back again. Back again. Okay. Here in the bamboo side, we have empty, void, no materials. Okay. So Professor Morisco would like to improve the capacity, the strength of this connection by injecting new material going to this inside. So next to Morisco idea. Okay, so like this one, please previous one. Yeah, they are inputting like mortar, cement, which has become a cement, sand and waters coming to these places. By doing this one, their connection will become stronger because the empty space inside, they will be replacing by, in this case, is the mortar, which is comprised of water, cement, and also sand, injecting this one. And here the example in the other one is become at the end of the bamboo column. The bamboo column is trying to become, it's like usually the round one, but now it's become tapers in the middle. So they can be going through one bolt coming to this cement mortar filling. So this is the idea how to connect. Next one. This is the example. The previous one is from Mr. Morisco. This is the filling gap. The void of this bamboo become cement mortar. Because, if we have only bamboo itself, the contact element between the bolted and the bamboo is just only in the outer face or maybe on the cross section of the bamboo, which is in the middle is empty. But now we are inserting more materials. Of course it becomes heavier, but there are more contacts on the bolted itself. So they can be strong enough to get more resistance on this connection system. Next one. And this one is proposed by Ota from Japanese University. So they are trying to press the end part of the bamboo, which is usually just round, and become flat enough. And they have inserting some wooden block. And doing this one, you can also connect bamboo to another, like you have solid wood section. You can drill a hole and you can connect with them. So this is the idea of Ota from Japan. Next one. And this is idea come from me, from civil engineering. In civil engineering, we are using FRP material, what we call fiber reinforced polymer. This is like a sheet material. You can utilize this one for repairing of any damage of structures. If you have concrete material, then you have some cracks. Then this is one way to repair it one. This kind of FRP sheet is like the way if you have any experience on working with wallpapers. Usually just the sheet and you put some epoxy and then you just glue it. Easy one. So this is the not orange, this is the magenta color. The purple color. So you just wrap it. In the middle we have one bolted. It just only to connect, because when we would like to apply this FRP sheet so they can stick together. So we applying this the purple layers is become from fiber reinforced polymers. And you will see here in the photo is the afterward. So before applying this material, you make sure that the surface of the bamboo is not sticky. It's not. It become not slippery. So you just make it become hard enough, and then you put some epoxy, and then you glue this PVC. After 1 month, oh sorry, 1 month, 1 day, then it becomes strong enough. It's become rigid. And please next see the next. This is the way we do the test, axial compression, and also we do some parallel connection or maybe parallel connection, and the other one is perpendicular one. So the A and B is different. So let's see the result. Okay, this is the idea. Let's see. You can see this kind of maybe bar chart. They can see. The one using the FRP sheet is in the middle one. So here you have the FGO is like using the natural fibers, but in the middle you have the FRP sheets. You will see the strength of the connection is much higher, 4 to 5 times stronger compared without any FRP reinforcement there. You can see the black one is. Yeah, so you can have A, B, C, the numbers. Then using this FRP sheet, we can get more connection system stronger, and also the stiffness is become higher. But at the time, I didn't consider the price. FRP sheet is much more expensive. It is imported from US actually. So bamboo is locally material one. But at the time, only the sponsor came to me and see what we can do with this one. So using FRP, because the idea is like wrapping the system, is like the natural fibers. We didn't initiate any hole on the system. But let's see if we are wrapping them, then we can also have better performance on the system. This is the idea coming to this project. Okay, next one. And then my student tried to advance the result using many kind of the whole way we are using the wrapping. This is, for example, here in the right side of mine. So you can see there are many kind of the way we are introducing, the FRP sheet. So from this kind of system, we can develop the connection as it is. Okay, next one. Okay, we do the test. The performance of this connection system is really amazing. We can have better 4 to 5 times strength of the connection, and also we have good stiffness. But then, yeah, the difficulty is that this metal is too expensive for us to apply it in the raw society. Okay, next one. Okay, now our connection system is now research on how we can using the steel wires to connect, and because the steel wire actually we can also do some trying to make it become that the connection become rigid on one to another member of bamboo. Okay, next one. So this is another one actually given by our researchers that we can also try to use the clamp system, which is the wooden block and also the bamboo column. So nowadays, if we would like to utilize the high strength of the bamboo, please make sure that the connection didn't initiate any hole or maybe crack on the system itself. So in my opinions, that we are using more instead of bolted connection, but we are trying to wrapping the system. But it's not only the FRP, but we can also using steel wire or maybe the natural fiber. But in many cases, natural fiber is not our preference because it's difficult. We have no more knowledge on this one. Okay, next one. So this is my formulation. This is the paper that finally I made, not made formally, but I communicated with David Trujillo. So when I wrote this paper, then David Trujillo, after a few years, he contacted me and tried to understand about because the paper written in Bahasa Indonesia. So David Trujillo would like to cite the paper, but he didn't know, didn't sure about the title from Indonesia to English. So this is way, and finally I know him well, and we are also now communicating on the system. So if you have the kind of bamboo connections, assuming that the gray layer is the steel, and the green layer is the bamboo, and the orange one is the void. you can put as a wooden block or maybe the mortar and so on. You have the black color is the bolted, and you have the one that behind, I mean, beneath the steel is like the failure area of the mortar or maybe the bamboo or maybe the steel plate. You can imagine this kind of possibility of the failures, one to another one. So it's just copying from the idea of the timber connection. Next one. So you have almost 6 possible failures, and you are trying to analyze the strength. For example, you have the properties of the steel dowel, you have the properties of the bamboo, you have the properties of the mortar, or maybe you have properties of the wooden block. So computing all them, you have 6 one, and then you will come up with the one which is the lowest. That are the possible failure of the connection at the end. So please, next one. Okay, there are formulation. I don't want to go in detail, but you may take a look later on. Next one. Okay. Connection. So this is the assumption. If it is failed, then probably the fail is because of the bamboo splitting, or probably of the bolted is bending, or probably they are also like failure because of the crushing of the wooden block inside the bamboo. So there are some possibility. Next one. Okay, next one. This is the one that we need to insert. And this is also our result from our previous study. We are trying to see the relationship between the embedding strength of the bamboo, which is something that we need to input in our calculations. And here, this is specific gravity of the bamboo. We can see that it is also copy from the idea of the timber, because the specific gravity increasing, then the embedding strength is increased as well. So this is the formulation. Then you can put in the calculation previously. Next one. So this is, for example, if you have the bamboo, 2 column, and you have 1 bolted, and you also identify the thickness of each column, and then you have the diameter of the bolted, also you have the bending strength of the bolted. You can calculate all those, and then you come up with this is our 4 possible failures, which is in the last 4 columns. You will see which is the lowest one. Then it becomes the failure of the connection. You can see here, normally just maybe 1 bolt, you can see that the number is around 10 kilonewton or 1 ton for 1 bolted. So usually you can just assume that when you have the 1 bolt connection, this is connection for 1 shear plane. So it's become, you need to make it double when you have double connection as it is here one. But you can see here they are the middle, they have to put some materials. If you are using not using any material inside the column, then the strength will become only maybe 60% from this number. So this is the calculation, then we can use it for our design. So this is things that we need to provide in our calculation document. And I didn't see, at the time, I didn't see any calculation related to this connection system. So yeah, I think when we are using bamboo for our building system, then we need to have this calculation at hand. So we can guarantee that the surface life of this building is reached by our design. Okay, next one. Oh, that's my last presentation. I riding my bicycle just to make sure that less emission coming from my self activity in campus. So thank you so much, and hopefully you have many questions for me. So I'm be happy to welcome and to discuss. Thank you so much.
Thank you for the presentation, Dr. Ali Awaludin. A very interesting presentation. We can learn so many things about connection in bamboo, which is the most challenging part from designing bamboo structure. I can see about the bolted connection. I see that in your book. So based on connection, but more challenging because in timber we usually just two component one slice or three component two slice, and now it's a minimum three component. So the steel, the bamboo, and the concrete or resin or whatever we put it in the space. So any question?
Halo, saya Emilia dari Civil Engineering Department. How are you, Mr. Ali? Long time not to see you. Can I speak in bahasa? Because my English is not so friendly. Saya tadi tertarik dengan laminasi dengan FRP. Itu kan kan luarannya kan licin kan Pak. Tadi Bapak ada menyebutkan harus di rough ya, apa mesti dibuat kasar, itu triknya bagaimana Pak gitu. Nah, satu, terus kedua untuk menyambung connecting dengan bolt, dia kan 3 komponen. Terus ada tadi usulan dari Pak Morisco kalau nggak salah ya, yang diisi dengan mortar. Itu adakah space-nya tuh jaraknya antara kan tadi bersilang ya, yang satu semangat sekali saya, yang komponen 1 sama 3 tuh sejajar, yang 2 agak naik. Itu jaraknya berapa ya Pak kira-kira dari ruas pada nodia namanya istilahnya ya. Terima kasih.
Thank you, Ibu Emilia. Maybe langsung aja.
Terima kasih Ibu Emilia. Saya jawab dalam bahasa Indonesia berarti ya. Makasih memberi kesempatan berbahasa Indonesia. Saya menerapkan diberi sandpaper dulu ya Bu, tapi tidak manually, tapi pakai drilling mesin gitu, tapi sandpaper. Karena tidak boleh dia licin, karena licin nanti epoksinya nggak merekat. Nggak melekat, jadi hanya di sandpaper. Habis itu lalu siap untuk dikasih epoksi dan dibalutkanlah FRP itu. Sesimpel itu. Tapi memang mengerjakannya harus pakai gloves ya, karena nanti bisa nempel tangannya di dalam bambunya tadi karena ada perekat. Ya. Lemnya tidak tebal, hanya 1 atau 2 mili, yang penting dia bisa merekat begitu. Nah itu keuntungannya kalau pakai FRP itu kan dia luwes, bisa ngikuti. Kekurangannya mahal. Itu aja kekurangannya.
Kan biasanya
ya,
kan ke
konkrit atau steel ini atau ke timber juga, tapi ini betul ya, karena punya FRP banyak, kurang kerjaan saya terus pakai itu aja lah mengerjakannya Bemila. Lalu yang kedua tentang pemanfaatan voltage ya pada area join. Memang kita akhirnya harus mengisi seluruh nodia itu. Di antara 2 nodia itu kan itu yang kita sebut internodia, itu yang harus kita isi dengan mortar atau wooden block itu ya, semuanya itu harus diisi. Karena kita nggak bisa membuat hanya sekian saja karena sifatnya di filling, di air dimasukkan, dan itu sulit sekali untuk bisa tidak mengisi penuh, harus isi penuh sempurna. Namun kawan-kawan itu kalau mendesain itu perlu concern bahwa bambu itu bisa shrinkage dan swelling. Beton sama tetapi rate-nya beda. One day antara beton isi atau mortar isi itu dengan bambu tidak lagi monolit, lepas. Ya itu perlu dipikirkan. Jadi desainnya mungkin walaupun kita mengisi mortar, make sure that bahwa di permukaan kayu yang dalam itu kan sangat juga licin ya, karena mengandung banyak tepung atau bedak gitu ya. Ya itu harus dikasarkan juga sebelum. Tapi kalau itu dalam bambu utuh kan kita nggak mungkin. Jadi itu tidak saya rekomendasikan, tapi kalau terpaksa bolehlah gitu ya, kalau terpaksa. Begitu Bu. Terima kasih.
Any more question from the student for Mr. Ali Awaludin about timber connection? Sorry, about bamboo connection.
I would like to ask a question, sir, because it intrigues me and about the beginning of your presentation about the collapse building in within of 2 months. You said that they built that building based on the timber standardization. Now, what I want to ask is in terms of bamboo standard as a material for constructions, what is the progress of the standard in the meantime? If there is any work that has been done to make that standardization, and I would like also to know, can engineers and researchers in Indonesia independently make that standard for the building and construction, or does it have to be internationally acknowledged? And what does it take to make that standardization of bamboo as a construction material? I think that's my question. Thank you.
Yeah, difficult question as well. Jadi, first is that a long time ago I talked with my colleague from Public Works Ministry how we can utilize bamboo as our construction materials. Then, as the material for construction, we need their mechanical properties completely. So all because within this all these engineering properties, then we can do some calculation, some modeling. But you always come to a problem how we do this grading system, because you cannot like you have to grading which one. I mean, column for each column you need to grading, because if you are having like experience on staying in like in Japan or maybe in Europe, if you are selling timber what we call timber, maybe solid wood, or maybe like timber pieces, they have the name, I mean they have the stamp on the top of this timber, which is mentioning about the young modulus and modulus of ruptures. But if you are coming to Indonesia, no one will see this one, and no one will will curious on this one. So they are using very low utilization of this product. And then what happened with bamboo? It's quite difficult. You cannot like you can say that this bamboo from visually you may say visually, but the mechanical properties is someone you have to test it. So we need to develop one kind of instrument to testing this one, but is this non-destructive one? For example, if just loaded one, you can see, oh, this is the young modulus is something. So this is something that we need to develop. By doing this one, some people may have may propose some empirical equations. If you have the bamboo column with this young modulus, okay, they may have the properties of tensile strength as it is, or maybe composite as this number, but these things relatively sort of data. So if you would like to set the standards, then the easy way is just to copy the standard from the outside. But so far I didn't know this kind of standard for design. If they are like standard for testing, yes, ISO is available. But standard for this bamboo has specific mechanical properties, it is not yet available. So by this one is make the bamboo is just away from our designer, because designer need the data for this kind of properties. So if we have, maybe next time, or maybe when the bamboo engineer researchers come together and they communicate and finally they can come up with one standards, we can use this standard in our country, so we can also utilize this standard for design and so on. We didn't have to wait for foreign, overseas to set up this one. But hopefully people who are joining this summer course, they know this is the weakest point and the thing that we need to work together to quickly finish this problem. Otherwise, bamboos become, is just, you may say, if the design is survived, then you are lucky. or maybe because you are so experienced so much, but actually the calculation is not available at the time. So that's my personal comment, I think. Hopefully, yeah, quite difficult to set up the grading system. But for example, in timber, you have the solid one, then you can have like static bending test. Okay, you have this kind. I mean, for example, the Young modulus is like, for example, 10,000 megapascal. There are so many calculations, so maybe empirical equation. Okay, if you have this kind of number, then the tensile strength will be around this number and so on. So this is it's already been established. So hopefully for bamboo, they soon become also follow this kind of the idea. Thank you.
Yes, any more question? Or experience, or maybe want to share to Dr. Awaldin? So can I ask? So yes, about the mechanical properties. So in timber, we can for non-destructive, we can use the specific gravity for calculating the elasticity. Is it possible if we do the same for bamboo? It's quite difficult.
Yes, difficult to answer, but actually in bamboo, in timber as well, we now did not rely only with the density of the timber. So it's not, when we have the density of timber, it's just only measuring the fibers content along the bamboo, along the wood. But you will not see any some cracks or maybe some damage inside the bamboo or inside the timbers. So now we are combining the way of grading system only representing by two properties. The first one is Young modulus. Young modulus can tell you many things, not only density, strength, but also its good properties to know. And the second one is modulus of rupture, which is not exactly from destructive test, it's just prediction. So they are predicting the data from Young modulus to become a modulus of rupture. So I think when we do a lot of tests on this bamboo, then finally we can come up with these empirical equations. But the first thing is we need to set up the instrument to measure the Young modulus of the bamboo. This is one way, because if you are seeing bamboo from one end to another end, which is anisotropic materials, non-homogeneous, then we have to come up with one data, because the engineer need this data to do calculation. So basically, it's good to set up the test, but I think we can also copy the way of the people in timber to do the Young modulus for the bamboo, but yeah, more research to verify this simplified model. Thank you.
But positive way is so many things can be researched in bamboo.
Yeah.
So
yeah.
Still many things can be researched.
Yeah. For scientists, bamboo is good because they play a lot of things to discover. But for business people, you need the data to do some calculation. Otherwise, they have no idea.
Thank you, Mr. Awaldin. Question? Okay, if there's no question, I give it back.
Okay, thank you to Mr. Muhammad Agung Putra Handana STMT, and I would like to get the audience to give an applause to Insinyur Ali Awaludin STM and PhD for the amazing, insightful, and knowledgeable presentations that give us knowledge about the overview of bamboo grafting, the problems of the construction with using bamboo, and the advancements research about the connections of bamboo. And hopefully this knowledge will give us insight and knowledge in order to us as a student and researchers to develop this in the future. And to Insinyur Ali, as a token of our gratitude to you, we would like to give you an ulos, a sign of culture in Medan, Batak, which will be given by Mr. Muhammad Agung Putra Handana, SDMT. Okay, thank you. Let's give an applause. Okay, once again, that lecture of overview of bamboo grafting was the lecture number 10 on this International Summer Course 2023, which also marked the end of our lecture sessions. In over the past 2 days, we already witnessed, listened, and comprehend 10 set of amazing lecture from our notably speakers, which one of them has his own expertise, and I hope that after we comprehend this set of 10 wonderful lecture, we can develop something, we can have an idea and inspirations to or develop in context of bamboo. So before we advance to the next sessions, I would like to ask all of the participants to take a picture together with all of us together. Let's set the stage here.